So I briefly introduce the event. Today we will talking about the Sunrise project. Sunrise is Horizon 2020 project. My name is Sara Tana. I just briefly introduce myself for the people that don't know me, that are almost the people that are in this room. I'm a dissemination manager, so this is a pleasure to be here and to organize the event, because dissemination manager is not a role that I have in this project. This is a role that I have in my company, that is Warrant Hub. Warrant Hub, it's a company that is devoted to help other companies to join European projects. So I have this role in all the European projects that we are managing, that now are almost 50 projects. So it's a really, really nice job, because we have the chance to see lots of results and lots of really interesting research, like the one that we will present today. So today the agenda will be the one that at home I think you can see. We cannot see it here. Okay. So this is the agenda of today. We will start with a brief introduction of the project by our project coordinator. So I was saying that after further presentation about glass recyclers in Europe, we will go in Brazil to understand how glass recycling is organized in that country. And then we will, after a short break, we will have a presentation of 3 of our partners that are connected online, and then there are round table, and then the closing remarks. Of course, we will keep in touch again after the event, because we are going to send you a short questionnaire that I will kindly ask you now to fill in it, to understand how what do you think about the potentiality of this project. So just to be brief, I introduce the first speaker of today. As I said, it's our project coordinator, Angelica Perez. So I ask you, Angelica, to come here at this stage, and I share your presentation.
Thank you for the introduction, Sarah, and thank you all of the attendees today. For us, for the project team, I think it's very valuable to have you here today, because are the ones which can show the interest about the project and which can benefit. And for us, it's a pleasure to take you today here. So I will make this first speech about the introduction of the project, but I have introduced it on other occasions, on other dissemination events, and today I would like to explain a little bit more about where are now in the project, some advances, and in order also you know what we are doing, and you can comment or see what is the possibilities. So I will start. Okay, this is this most of you know which is the problem. I will very brief explain. In case someone online don't know about which is this waste. But okay, we are talking about laminated glass in this project, recycling of laminated glass. This is formed by bonding glass layers using a polymeric interlayer, which usually is PVB, but could be another polymers. And okay, this material is recycled by glass recyclers, by you, most of you here in the room. And the issue is not the glass, because the glass is recovered, and the issue is the PVB interlayer. This material in the recycling process is mostly considered a waste, because most of the times it ends in incineration, landfilling, and only a very small percentage is recycled. So which are the challenges for PVB recycling, for circular PVB recycling, because there is some small recycling in minor applications, but the challenge is to recycle it for the same application or for a high quality application. here there are 3 challenges as we identified, but it could be more. One is the glass content in the recycled PVB, which results in haze and turbidity. The second one is the aging of the laminated glass and the PVB, because they use phase, but also because sometimes it's aged for the recycling process. And the third challenge aspect is that variability of PVB compositions. So when we obtain these waves, this blending of different types of PVB, then could be a blend with other polymers which are not PVB. And these different compositions and functionalities makes that it can be difficult to make again the use for it in the time. So this create this project, this Sunrise project, this challenge. We some data about the project. This project was created during the pandemic, so we were very inspired by the pandemic in our house's writing. And okay, the starting date was 1st June in 2021, and have a duration of 3 years and a half. We are now in the second year of the project, so we have 1 year and a half more of work to make. We are 20 partners in the consortium. The global budget is 9 million and a half, more or less, and the contribution from the European Commission is around 8 million. And Lourdes Technological Center is coordinating this project. Some background about this. Okay, Lourdes was working in the past about PVB recycling, not with this focus in this project, which is developing these sensor sorting tools, but was working in this recycling. Lourdes is a technological center, and okay, we have different areas. Within these areas, we have areas related with recycling and environment. So these areas of recycling, we work in recycling of different types of materials, some waste, electronic waste, biomechanical and solvent extraction process, but we have also some areas related with materials, for example, with plastic processing. So these areas makes that Lourdes have this knowledge and could act as coordinator. Also, we have some expertise from FP4 in European projects, so we have this role sometimes in the projects as coordinator. So once I explain the background of why we are here today with this project, I will go to the structure and objectives. This project have like 4 parts in the project. One is we have some recyclers in the project, which works not only in the initial phase of the project, but also throughout all the duration. Then we have a part which is related with the optimization and design of the recycling line. Okay, so the project is based in developing a sorting system which can classify in different categories the PVB. The PVB when still in the glass, so we sort the glass, the laminated glass, and PVB difference. So this is the phase we have been involved until and up to now in the project, the design of the sorting system, the methodologies, and also the optimization of the mechanical chemical blocks. So this has been the phase, and now we will start the part of the processing. Okay, we will obtain PVB flakes categorized by different aspects. I will comment after that. And we will make different formats for the different applications like pellets, film, or dispersion. And finally, we have a final end phase related with the end use of these formats in different applications for laminated glass, but also for energy storage and coatings and textiles. So this is the 4 phases of the project. We have also some global aspects related with the standards, with dissemination. This is our methodology. We have structured this work in 9 work packages. Just now we are in the 24th month, so we have closed work package 1, of course, regarding definition, and mostly closed work package 2 regarding the offline characterization of PVB, the methodologies development, and the chemical and mechanical pilot line testing. And then also we have mostly closed work package 3 regarding the design, optimization, and construction of the sorting system. So now I'm going to try to explain the most important objectives where we are now so that you can see the status. Okay, the first objective of the project, or the most important one in this project, is develop this multi-sensor tool to construct this system, which includes some mechanical feeding, putting, and positioning modules coupled to a multi-sensor tool, which will subsequent goes to an actuator module to divide the different types of glasses. So this sorting system allows a fast inspection and assessment, lower than 25 seconds, and is a prototype, but we are aiming for this prototype 100 laminated glass per hour. So how is working this? Okay, we assess, this is configured like a step to a conventional recycling. So we assess in the glass, this is a picture of the windscreen, but it could be another type of glass. We assess in this, in the case of the project, in a sample, not in the full windscreen, but it will be extrapolated after that to this. We measure in the windscreen, and then the sensor identify the category according to PVB composition and quality, and then the sensor makes their decision and classify for a category. This could be a pre-sorting step in the conventional recycling, and then this should be by batches to different treatment of different batches. So this is the idea of the sensor. Just now, what has been done in the project? In the project, what the methodology we have followed is to plan, first to make offline characterization of PVB from reference materials and from waste according to offline characterization techniques, including infrared spectroscopy and MR, PGA, and others, in order to have a first database with the characterization results. And then in parallel, in this PVB within laminated glass has been characterized by spectroscopic techniques. These are different spectroscopic techniques that have been used in the project, like Raman, NIR, retransmittance, reflectance, fluorescent, and point spread function. And we selected these ones for assessing our criteria. Just now, these the selected ones are Raman and NIR spectroscopy, which can identify if it is PVB or not PVB, and if can identify also the plasticizer type. Then for the degradation, according to transmittance and yellowness and haze, we evaluated with transmittance spectroscopy, and also the haze can be assessed with a point spread function. So this has been, the methodology is developed according to these sensors has been developed and optimized, and now is being constructed this multi-sensor tool. This is the appearance of the prototype of the part of the sensors, where each probe head is located, the Raman, the NIR, and the integrated probe head, including the transmittance and haze measurements. So this prototype is now being constructed. It will be end in September this year. So we are ending this part. So something to comment about the sorting categories. Okay. The sorting categories we have identified, okay, we have, according to these methodologies, according to this characterization, we use, in addition to the sensors, some artificial intelligence algorithms for assessment of the laminated glass waste, correlating the data with the target properties and sorting the laminated glass waste in different categories. So these categories, just now, I don't know if it is very small letter, but I will explain. We have identified, the multi-sensor tool will be able to identify category one, like a high quality laminated glass waste, which will be PVB. We'll identify that this is PVB. And in addition, this is high quality. The criteria of quality has been done according to haze and yellowness. Okay, both will give similar results. So we have identified haze as a faster measurement. And we have set some threshold of haze below 20%. Then within this high quality category, we will have different categories according to the type of plasticizer. We have made some database of plasticizers, and we, in the final assessments, what we have been seeing is that mostly of the waste and mostly of the materials has 3-ethylene glycol ethyl-hexanoate plasticizer, but in some occasions there are mixtures of plasticizers with this and other plasticizer. So we will probably have one category 1A and 1D for only one plasticizer and a mixture of plasticizers. So then we are working outside of the initial planned aspects to introduce an additional potential sorting category, which is the content of the plasticizer. With Raman, we can assess, so we can make some training of the sensors with the PVB and different content of plasticizer, and we could try to identify plasticizer compositions below some value and higher some value. And this could be also interesting for classification. And then we have a category 2, which will be PVB material, which has a high haze, high degradation, and category 3, which is rejection, non-classified or non-PVB. So we will have these categories. And okay, these schemes here are some measurements we make about the evolution of haze and in this case haze, but also yellowness when we made some artificial degradation of PVB and this PVB was laminated. We made some assessments of how haze was increasing when there was some degradations according to ultraviolet degradation and repetitive destruction time. So this was also some studies we made in order to help to decide about the sorting criteria and threshold. So this about the categories. Then about the mechanochemical treatment. One of the objectives of the project is to integrate a previous sorting module to a mechanochemical pilot line. This pilot line is in Lourederra. It was constructed before the project, not in this project. And this line has a capacity to produce 360 kilograms per hour of PVB, it's clean PVB. How it works? Okay, we have 2 steps. Okay, on one hand, we can make some mechanical conditioning of the waste. Okay, how we have been working in Lourederra, we have been working from full laminated glass, obtaining the PVB flakes and then we clean. But also we have been testing directly PVB flakes from recyclers. So in some cases, this additional needs some mechanical preparation for removing more glass previous to the chemical steps, and also for shredding the PVB, which will be needed in the end. And then we have the chemical treatment. This chemical treatment consists of 5 steps, 5 alternate washing and acid and basic steps of cleaning, where the acid cleaning makes weaken the bonds between glass and PVB, and then the basic treatment neutralize the previous step. So this is the process we make. Here are some results about the content of glass. Our target is having a glass content at the end of the process of 0.5%. These are some results of automotive waste where it's possible to reach this value and lower values. But in construction is more challenging. Depends a lot of the variability of these wastes because when we have very thicker glasses, also this difficults the process and probably the mechanical conditions will be more improved. So that's about the mechanical recycling, mechanochemical, sorry. And then another objective of the project is related with the construction of a software tool, a decision support tool, for optimizing the recycling process. The mechanochemical processes are modeled and they are with semi-empirical equations that correlates well with the first has been correlated with literature data, and now are going to be correlated with experimental data from the project. And these equations will model and will be programmed by Python library, and this then will be connected to a web app that is constructed by Blazor. And this app will allow the user to optimize the parameters according to, for example, how is the content in the beginning of class, how I would like to obtain in the end. So to optimize something, the parameters according to characteristics of the waste. And finally, going to technical aspects started just now. Okay, most of the part has been done in the part of the sensor and the methodology, but we have started preliminary tests of granulates and film production. Not with sorted material because it's still not constructed the system, but with mixed material, only classified by automotive or construction waste. And here, Biomi and Ariño worked in Biomi in the production of PVB film pellets first, and then film, starting from the recycled PVB. And we compare also with other recycled PVBs. And okay, for the beginning, without sorted material, we have some lessons learned about this processing of PVB. On one hand, when we compare with other recycled PVB flakes, this was the one of the project was much clearer film than the other benchmark ones. We make some preliminary testing with Ariño, not with these films, make at pilot scale, but some laboratory previously developed films. And with these films, okay, we see that the haze is still high, so we will need to mix with virgin PVB. But this was not, in any case, optimized according to the process of the film or of the laminated glass, and was with not sorted material. So probably with sorted material, we will have also to mix with virgin PVB. But okay, I think it will be a possibility to have within the requirements. And then finally, we need to control the stickiness. It's true that the PVB needs to be adhesive because it's one of the properties, but for the processing, we will need to add some additives because the thickness of our PVB was higher than from the other recycled. So this is our preliminary test. Now we are going to enter in this phase of the project where we are going to processing this recycled PVB flake in order to additivate for a new life. So we will go more in the next year about this. And other applications, this is another objective of the project, to revalorize other PVB fractions for other applications in coatings, carpets, and energy storage. I will not go deeply here because some of the partners will advance today, which are going to planning in this part. And finally, regarding the first initial techno-economical and environmental outcomes, this work package about sustainability was in parallel most of the duration of the project. So here, what we plan is to assess the impacts, economic impacts, and environmental impacts compared to current end-of-life scenarios and with virgin production of PVB. So finally, we planned some comparison about the process in that way. And so we consider in this assessment, okay, you will see this scheme here. This is the full process. The red boxes are the ones, additional steps that Sunrise Project plans. So we plan a pre-sorting step, then the conventional recycling, and then probably mechanical conditioning for part of the waste and a chemical conditioning for cleaning the PVB. So we consider these red steps as additional steps for the PVB recycling. Then we can compare with the PVB ends scenarios just now, like incineration and landfill. We make in this way. As the conventional recycling, the target is the glass, and as commented with Ferber, it was okay, it will be separated as our steps are focusing in the PVB. So when we compare in terms of life cycle assessment, so the results, compare the recycling scenario with an incineration scenario with a landfilling scenario. And the results are good, as could be expected in terms of environmental aspect. These are the different environmental impact categories for the different scenarios, and Sunrise Recycling is best in all the cases. If we go to some targets we have in carbon footprint reduction, we are almost in an 80% reduction regarding incineration scenario and a 70% reduction regarding landfilling. We make also some methodology to assess health and safety risks. And also there is a big important reduction in these aspects regarding both scenarios. So from environmental point of view is something good, Sunrise project. One aspect to comment here, when we model the different scenarios, we take into account the PBB that is avoided from primary production. So we have to modulate the PBB primary production, but we don't have available a compatible library for PBB polymer production. So we have to make some approximation, which was a conservative one. As we don't have the PBB primary production, we consider one of the precursors of PBB, which was vinyl acetate. We will try to make the full, we will try to obtain this PBB primary production, but in any case, we have considered a precursor of PBB. We have considered and lower impact the primary production, because with the additional materials, PBB primary production could be indeed have more impact. So we have been conservative, and indeed in this case we have good advantages. And okay, regarding there was some effects that directly have been put in the slide. So regarding the economic aspects, we make the comparison in the same way. Recycling regarding incineration and landfilling. Okay, behind this picture we have some additional information hidden about the cost of landfilling and incineration for the recyclers, the cost for PBB, which could be around, I don't know, I don't remember, but up to 160 euros per ton, for example. And we have the scenario of PBB recycling. Here we make the evaluation of these steps: sorting, mechanical conditioning, and chemical module. In terms of economics, we make some initial estimations according to the prototypes we have in the project, and we obtain some price for the PBB in PBB flakes format. It was around 1,700. What we can see here is that the mechanical part, if you see this color here, is from the mechanical part. It was higher, have a higher cost repercussion, but this could be explained because in our pilot system, this equipment is the lower through output. It's a pilot equipment, and it could be in a real situation we could have a very higher through output like in the mechanical part. In this case, we made some estimations also about cost repercussion if we go to a industrial system for the mechanical part, and we could reduce this price around 800 euros per ton. Here we compare with some with some market price of other recycled PBB flakes, and we were very close. We will have some 1,000 euros per ton for recycled PBB flakes in the market from some providers. So we think that could have a very good opportunity. Of course, this has to be reviewed with not only with estimations of higher scale of the mechanical part, even for the sorting part, because we could extrapolate also the sorting part to a higher output. And also we should consider here some benefit part, because these are costs, not benefit included just now. But the results indicate that I think it's not a matter of price, it's a matter of the PBB we obtain can have a really technical value and a market. So we could obtain this. And finally, to close this, all this work I have presented has been done by the Sunrise project, which is a team of 20 partners. I will mention here the partners, which are divided by research partners. Here we are Lurederra, IREC, National University of Athens, IDENER, Politecnico di Torino, and Next Technology Textile. Then we have some business partners. Okay, we have equipment providers like Lens and Ingeniería Navarra Mecánica in Spain, both of them. Then we have a waste collection and materials recycling and materials producer in the project. We have Minerali, Dismeco, Ferber Association, and Biomi. And we have product manufacturers. We have MedSolar for the production of PV, photovoltaics. Then we have Ariño Douglas for the production of laminated glass in railway and construction sector. Evadex for coatings using PVB as binder. Antepower in batteries and Radici Group in textiles. And then we have in our value chain some supporting partners for complementing, Ferber again as stakeholders in the project. We have DEAN Association for the standards, the team for environmental assessment, and Warren Hub for dissemination and stuff. So this is our team. To close my speech, I would like to motivate to follow our dissemination activities. This is the calendar of the next webinars. If you have followed some of them, you know that there will be in the next year. And okay, we will have this has been our first workshop here in Copenhagen, a very nice place. But we are planning a second one next year, probably in the same months. It's open to the summer. And we'll be in Urederra for seeing this demo sorting tool and the mechanochemical recycling facility in our facilities in Urederra in Spain. So we would like to motivate all of you to attend also this workshop. And I think no more from my side. I don't know if there are questions, so you can. Yes.
Someone has any question? Also from home? You can think about it, and then we can talk at the end of the event. If you have any question, we are here to answer. Thanks to you. Oh,
maybe one question from my end. It's Christoph here from Curare. For me, it seems that this 20% threshold for haze is a little bit high if we really plan to reuse it in an extrusion line.
Okay. So this was something in the beginning we have a lower haze value, but because really the haze value for the manufacturer is, I think, 1%, but this 1% is measured according to it depends in the glass thickness, it depends on the color of the glass, it depends the PVB thickness. So when we have the waste, we have different thicknesses in the glass. And we have also different colors. I mean, a windscreen, when we measure the haze, we are measuring throughout the glass. So when we measure a reference windscreen, for example, we have already an upper or a high haze. I don't remember, but probably we have a 10% of haze, and it is a good quality. Always because depends on the color of this glass and the thickness of this glass. So we need to make these degradation studies to see where could be a change, and finally we decide this 20%. It's in some occasions 20% could be high, but what we see from the degradation studies from assessing different reference and waste materials is that could discriminate where really we have a bad quality and when we have a good quality. But that's the reason is the one that I mentioned in the beginning. We are not measuring with a fixed glass thickness, so it's very variable, the haze, according to the type of waste we are measuring.
Okay, thank you for the explanation.
think that there are no other questions, so we go on. Our next speakers. Just share the presentation. Okay, so I have the pleasure to introduce you to Sir Badwainska. If you want to come here to present talk. One is the Vice President of FERVER, that is the European Federation of Glass Recyclers. And he has a master in biology, toxicology, and environmental engineering. So he spent his career in different companies, active in waste management, recycling, and emergencies before joining the Belgian Waste Management Association, the NUO, that is partner with, of course, with FERVER of Sunrise Project. So please, the stage is yours.
Okay, thank you. Good afternoon, everybody. So as explained, we are with FERVER, being the European Association of Glass Recyclers, managed by the Belgian Waste Management Federation. We are partners of Sunrise Project. FERVER represents roughly 70% of the recycling of glass in Europe, focused on packaging glass. We have 7 members in 17 countries, 40 members, 80 plants, and more than 2,000 employees. You have the logos of all our members, and in green, the place where we are present. Our members are recycling packaging glass, foam glass, glass powder, flat glass, and PV glass, of course. And you see in blue are the countries where we only have members active in packaging glass, and the other one is flat glass, packaging glass, or compound. We have to add, for example, in the Netherlands, you see Netherlands in blue. It's quite strange because Netherlands is the only country having a green dot system for flat glass. But our members active in the recycling of this glass have their sites outside the Netherlands. That's the reason why you see Netherlands in blue. Romania and Turkey, we also have their members active in flat glass. Okay, we try to have, let's say, a picture of what is available as PVB on the European market. We launched a survey covering Europe and also some non-European countries. You saw on our map, I forgot to mention it for you to clarify the situation. We have 3 non-EU members being UK now, Norway and Turkey. The other members are European. And you see here, we launched a survey covering, we got answers from 24 members, 24 companies, from which 3 were outside Europe. And in the 24 answers we got, 21 were really active in flat glass recycling. We got this picture, the quantity you see on the screen, 1 million ton related glass waste collected, generating roughly 80,000 tons of PVB, knowing that this PVB waste still contains some glass, roughly 10%. That's the reason why we have to work with Sunrise to purify the PVB and to try recycling it. Just to give you some comparisons with the packaging glass, and that's one of the most important point in our activities now, is that for packaging glass in Europe, you have very clear and very strong legislation. Europe is now busy even to move the packaging and packaging waste directive in a regulation, bringing the rules more strict, more stringent, and a real level playing field between the countries, because all the rules will be applied de facto as such in each country. You have an obligation to selectively collect the glass from packaging, which is not the case for flat glass. We have now, let's say just before time, because on the 20th of June, the Commission will publish a proposal of once again, a regulation instead of a directive for end-of-life vehicles. And we, as Fairware, and together with the partners, we advocated to have a selective target for the glass, because we have to know when you have an end-of-life vehicle, that goes mostly for recycling of metals. They go to the shredder, and at the moment the glass is mixed with the metals, you can forget it's recycled. Contamination is so high, you can only use it in the best way as granulates for road construction, but no more for the closed-loop recycling of glass. That's a bit. For construction, they're the same. For construction, there are no specific targets for glass. There is only a global target at European level of 70%, even not recycling, it's recovery. So energy recovery is also covered. And of course, 70%, you don't need the small percentage of glass in a building to reach this 70%. And if you have no pre-dismantling of the windows in a building in the context of demolition, once again, like for the car, you can't forget it's recycled. Most of the flat glass now recycled comes from the renovation activities, where we have, of course, replacement of windows and new kind of pieces. Okay. Then the survey we did, you see roughly 63% of people got waste from construction and 33% from automotive. That's quite comparable with, let's say, repartition on the production, which is from the European data, 83% from construction and 17% from car. We have a little bit more presence here of car. And the 21 plants we got information from are all recycling both categories. So we have no recycle only for one of the two categories. The other 4% represent probably pre-consumer waste that get directly from the production sites. When you see now what kind of laminated glass we collect, because of course, if we want to close the loop with PVB, we have to know the quality and the origin of the material. And that was a multiple choice answer. Therefore, we have not the sum of 100%. Because all the members got also, most of them, PVB glass coming from the different sources, being post-consumer laminated automotive glass from dismantling, from repair, you see even more, and that's clear that repair is like in the construction. When you have renovation, you have the glass clean. In repair, you have also the car glass colleagues and boys. You have them on only glass. If it's end of life, that's more tricky. Demolition, the same renovation, more renovation than demolition. And then, of course, pre-consumer laminated automotive and pre-consumer constructive glass as well. An important aspect of the recycling is the storage. Of course, the 20 recyclers are glass recyclers. The activity is focused on glass to deliver glass in a most efficient way. And you know that most of the glass is sold as raw material to produce new glass. In the survey we do within the members of Fairware, 90% of the glass the Fairware members recycles get the stamp of European end of waste. That means it's again a product which can be used to produce new material, and in the most case is to produce again packaging. Therefore, they do not spend too much attention now to the PVB, which is a waste. And then we see more than 80% of the members having PVB on their plant, store it outside, because it's the most easy place to store the material before exporting. Inside, less, and also more than 20% are mixing laminated and non-laminated glass. We will see that's an important parameter in our study. The objective is, if we succeed in finding good solution for, let's say, as close as possible load for PVB recycling, we will have to pay more attention to the PVB. And one of the most sensitive issues for PVB is the reaction to ultraviolets. When you have UV on PVB, you have, let's say, degradation of the polymer, and you can no more use it because the transparency is reduced. And then you can use it as glue or something like that. But let's see what we call downcycling instead of a closed loop acting. Now, again, when we ask, and that's a qualitative and let's say a little bit subjective appreciation we ask to the members, how do you classify the quality of the PVB you have on your stock? And you see that's quite equal for both categories, the post one on the left and the best one on the right. Now, considering the destination today, you see roughly 40% goes to landfill. That's pity, because when you see the price of PVB and the quality of this material, we dream to do much more than what we do with it today. Even in some countries, it's now forbidden to landfill organic material. So you have to go to waste to energy plants. That is considered officially by Europe as a recovery activity, 30%. And still, well, say 20%, we are in the good direction, 20% are recycled. The other 11% is most in most cases storage, in the hope to find a better solution. Now we saw what Angelica explained with the LCA and LCC ongoing. I must say that not giving it exact data, but most of the members now and most of the recycling plants dealing with landfill, waste to energy, and even recycling have today to pay to get rid of the material due to the low value of the recycling processes. Some get limited positive value, or is it free of charge, but then they have the cost of transport. And there is certainly something we hope to modify. I dream to, after the 42 months, to come again and to have, instead of this cake, to have, let's say, recycling on the below left and the landfilling above. But that's a future. Okay, that's roughly the presentation I had to for today, and I thank you all for your attention. Thank you.
Question? Not in the room. Anyone? Yeah, one question.
About the PV recycling. I saw
Sorry, because sorry, one, because I take the microphone, because otherwise I cannot hear you.
like to know about the PV recycling. Because from the statistics, it's probably a very small part.
Yes.
The glass from PV. So
Photovoltaic panels.
yes. So from the photovoltaic panels, you are recycling just the glass, and everything else going to the landfill, probably.
No, well, there is an increasing market, of course, because
Yeah.
a lot of people are buying now PV panels, but are not yet leaving it as waste. And you know, the lifetime is 20 or 30 years, something like this. At the beginning, we had some, of course, the biggest part is glass. So the first contact we had with glass recyclers, and you have here in the room some people active in PV recycling. What we see is a trend that the frame of the PV panel is aluminium.
Yeah.
And we see a shift now that metal recyclers are more interested and more involved in the PV panel recycling. And they try to get rid of the glass fraction after maybe purification and separation, with then the glass recyclers in a second step. But maybe some members here can give you more information about it.
One here.
Yes, maybe I can.
Of course. Because maybe the European Federation of the production of
Flat.
Flat glass, including PV pipes.
Yes, yeah. So we are actually actively working on this issue of solar panels recycling. As you mentioned, they're just now coming at their end of life, so it's really the beginning of this whole issue. But you probably also know that there's a trend at European level to try to be more energy dependent, to have more renewable energy, and therefore a kind of industrial policy also trying to go into that direction. There's the so-called Net Zero Industry Act, which has been proposed by the European Commission a few months ago in March. And actually, Glass for Europe, so the European Flat Glass Federation, we are members of a solar alliance at European level, also looking in those types of issues. There are some issues with glass recycling in solar panels, mainly because we don't know the composition of glass there. Most of it coming from China, so that's a kind of hurdle. But yeah, we can discuss afterwards if you want on more the policy aspects of it as well.
Yeah.
Yeah. Regarding glass recycling, we have just installed this week the first recycling plant for PV modules in Germany, which is only taking PV modules from the market with a capacity of theoretically 50,000 tons per year. And we have the full aspects with the reuse. So we also look for if the modules are still okay and can be reused for small power plants for private people, etc. And all the other material we go and give it to the recycling. Of course, the aluminium is a fraction which is separated. The glass is what we are focused on and where we came from, because we are flat glass recycler, but also the other aspects, the raw earth, etc. materials are in our focus, but not ready to be recycled right now. And the foil which comes out of it is going to incineration in these days. But again, it's installed, it's ready and approved this week, and we are taking these materials from the market. Silicon-based, not no modules with heavy metals. So cadmium telluride, etc., is not going to enter our gate, but all silicon-based modules, which is 95% of the market, we are able to take. And the plant is located in Münster, Germany.
Thanks for your contribution. Okay, we can go on. Someone has any question can, of course, switch the microphone on and ask. Okay, here you are. This is the presentation from one of our invited speakers that I would like to thanks for being here from Brazil, Juliana Schunk. She's graduated in business and post-graduated in strategic and business management, and she's dedicated to the waste market in Brazil for 15 years, where she supports the development of the glass recycling chain together with public ambient and glass industries in the company that is called Masfix. So if you want to start, Juliana, the stage is yours.
Thank you.
Thank
Good afternoon. It's a pleasure to be here with you. Europe is our reference in everything we do in waste management and glass recycling. So I'm very happy to be here and share with you some information about our job in Brazil and what we've been doing in over 30 years, recycling glass in Brazil, and over 20 years of recycling laminated glass. And this issue of the PV is always a bigger question for us as well. And we produce almost 300 tons per month of the waste PVB. and we are we're looking forward to a solution, and that's why we are here. And well, Masix is a glass recycling company, and we were at the beginning very focused on flat glass, and then started with laminated glass, and since 2013, collection as well, packaging glass. I brought here some numbers, and last year we recycled 200,000 tons of cullet. We have 250 employees. The half of them are focused in logistics, because in Brazil we don't have an organized system of collection, so we need to do by ourselves the collection. So we have 72 trucks, and we collect the cullets in our supplies, and we served 18 states. We have 2 plants in São Paulo, and the majority of the glass industry is in the coast of Brazil. So we need to recycle our glass in the coast. So we have 2 plants in São Paulo, 1 under construction in Minas Gerais, and we have some points of consolidation where we can collect the glass in this area and then transfer to a plant in São Paulo. And just to give you an idea, these points of consolidation are 1,000 kilometers far from our plants. So we have a very high cost of logistics, and we don't use boats, we don't use trains, we use only trucks to transportation. So this is our big challenge in Brazil. I brought some products that we're recycling. We produce 8% of our material goes to the glass industry, packaging or flat glass, and the rest goes to another segments as ceramic industry, abrasives, and microspheres, and others kinds of smaller users. Talking about the laminated glass marketing in Brazil, just bring some numbers. We produce 2.37 millions of cars per year, and our fleet of vehicles is 45 million cars. So about 5% of this fleet replace their windshield per year. So we have a big number of laminated glass. And in the construction civil marketing, we produce 390,000 tons of glass per year. We assume that 10% of that number is lost and what we can recycle. The circular chain of the laminated glass, that we have the flat glass industry, and then the transformation of the production of laminated glass, even for vehicles or for construction, and then they distribute this glass, where we recycle the glass, and then sell again to the flat glass and the container glass industry. The origins of the laminated glass that we collect, 42% is pre-consumer or industrial, and 57% is aftermarket, where we have a very high cost of collection, because we need to collect point to point of this glass, and we don't have regulation of the ends of vehicle in Brazil, what is a problem, and we have a very strong metal industry there, that they are starting to crush everything, and the glass as well, what is a problem. And we assume that we have 20 million cars abandoned in Brazil, so a lot of glass and a big opportunity to collect this glass. And in Brazil, we have different markets that are the bulletproof glass. And last year, we collected 800 tons of this kind of material, where you can find a lot of PVB, and this is a market that is growing 30% a year. Last year, we recycled 36,000 tons of laminated glass, and we are the biggest recycler in Brazil, but we have some others smaller recycling doing the same job. And as I told you, the flat glass industry and the container glass are in the coast, so that's why we need to produce and collect it only in this smaller area. Talking about our process, Badwin showed us, and our numbers are very similar with yours. We have about 10% of glass in the PVB. Our process is a crusher and mechanical process where we crush, and then crush again the material to separate the glass from the PVB. We produce 300 tons of PVB per month, and 10% of the glass is in the PVB. And this is our challenge in Brazil, and that's why we cannot give a more valuable destination to the PVB. And 20% of the glass recycled goes to the flat glass industry, and 8% goes to the container glass industry. And the PVB, as you hear, we destinate a part of the waste material for the energy waste, and the biggest part to the landfill, and the smaller parts, like 10%, as artisanal process that can clean the PVB and aggregates in other materials. We have in Brazil a very good market for the scrap of the clean PVB. So they mix both of them and try to evaluate a little more the PVB, but it's a small volume. And now in Brazil, we are developing some research with university and with the Saint-Gobain Research Brazil, that they have a very good structure there. And 70% of their researchers now are about recyclable materials. So they are very focused in this kind of material. That's it. Thank you very much.
Question? The audience here? Everything is really clear. Someone from home? From home? Okay. So if everything was clear, or if you want to think about any question to do with our speakers after, you can do it. Now we have a little break. We have a short break of 15 minutes. So I ask you to be on time here from 15 minutes, and this break, and see you after the break. Okay? Many thanks. We start with the second part of the event. Now we will have a presentation regarding the potentiality of re-PVB.
So in different application, in textile, in photovoltaics, and in energy storage. Many thanks to the speakers that will present this part. The first one is Daniele Spinelli. Daniele, hi. Daniele, you can switch on your camera and your microphone. Hi, good afternoon.
Hi, good afternoon.
Good afternoon. So in the meantime, you share your presentation. I just briefly introduce you. Daniele Spinelli is one of our partners. He's a PhD degree in chemical sciences at the University of Siena in Italy. Since 2017, he's working in Next Technology Tecnotessile as member of the Chemical and Technological Research Unit to support companies for competitiveness improvement. He's experienced in EU-funded projects, both in Horizon 2020 and Horizon Europe, projects mainly related to textile, to sustainability, to circular economy. So, Daniele, if you want to start, the stage is yours.
Okay, thank you, Sarah, and thank you all for this opportunity. So, my name is Daniele Spinelli. I'm a project manager at Next Technology Tecnotextile. We are a research organization located in Italy, mainly in Prato. And the organization was founded in 1972 with the main goal to push innovation for textile companies. So we are quite involved in research activities related to innovation on textile, mainly at the product and the process level. We are a group of 21 people that are working mainly on research activities and also to act as a technological transfer institution, mainly to different technological priorities that are at the moment focusing on circular economy, sustainable textile, Industry 4.0, chemistry and nanotechnology, and ICT and photonics. So our institution is quite connected with company and mainly with the needs of companies. So today, textile companies are searching for innovative solution and also to thinking a possible link with other industries and also mainly connected with the industrial symbiosis concept. So this is because sure our involvement in Sunrise project is one of the key challenges that we would like also to push, try to find a possible application of recycled PVB also for textile application. So our institution is also leading OTIR 2020, that is a Tuscany fashion cluster. So we are connected more than 400 companies that are mainly SME in order to help them to reach innovative solution. Also try to find the link with the European institution, also research activities, but also to establish a new collaboration, a new market business with other companies among Europe. We have also a certified lab that is named the CQ, Center of Equality, to monitoring mainly the key performances of innovative material before to go on the market. And we have a quite long experience in European project, mainly now in Horizon Europe. In terms of main activities and competencies, we are supporting textile companies and also to introduce new technologies, but also starting from new raw material selection until to obtain final products, mainly for fashion industry, but also for technical textiles. So mainly we are quite involved in recycling solution, but also to use innovative materials in order to find alternatives to the market. So Mainly we are involved in technologies for modification of materials, but mainly pass from functionalization of the surface of textiles, but also developing also novel chemical processes and approach. As I said before, at the moment we are quite involved in circular economy and sustainable textile practices. For circular economy, we are also interested in sorting technologies for textile, but also chemical and mechanical recycling. And sure, sustainable approaches like the possible reuse of PVB for textile coatings is one of the challenges that we are addressing, but also the possibility to use bio-based and sustainable chemical compounds for textile finishing, because as you know, is also a step in the textile value chain for which we are expecting to substitute the conventional fossil-based solution. We are quite involved also in composite sector. Mainly we have collaboration with sector like packaging, automotive, furniture, and buildings. We have also done some experience in treatment and reuse of industrial wastewater. We have a unit in entity that is involved in mechanical devices and different machinery development in a customizable form. And we have also, or usually we are also supporting R&D processes related to automation and the control system. Starting from 5 years ago, we are also supporting textile company to evaluate the environmental footprint at the product and process level. And for that, we are also consultant companies of Prato Chamber of Commerce. So going a little bit on detail about our involvement and interest for textile sector about PVB. So PVB is quite interesting polymer because sure can be used for different application, and the possibility to valorize PVB starting from sure the possibility to reuse in a recycled form could be also an advantage also for the market, because the manufacturing of a PVB from raw material utilize more energy and it's costly. So it means that if we can find some solution to also recycle PVB, also decreasing the carbon footprint for similar uses, but also to find a new link in other market, it could be quite interesting. And sure, it's an interesting opportunity because we have an increase in demands for this polymer, mainly, for example, also for photovoltaic industry. So as you know, also in Europe, we are also pushing a lot on the use of sustainable energies, and also photovoltaics could be one of the key technology to guide the European transition through a Green Deal approach. And another point is that also we have different and stringent environmental regulation. It means that we should find a way to reuse PVB also for the market and also for other application that could be also quite new, as in case of textile coating. So textile coating application are quite interested not only for an aesthetical point of view, but also for a functional point of view, because mainly for technical textiles, but also for fashion industry, the sector is quite interested to find functional solution like hydro and oleophobicity, or flame retardancy, or antimicrobial effects. So there are a lot of key properties that we need to push for textile application, like for example also in medical area or for textile building or automotive sector. So all these sectors are requiring a lot of functionalities. And so one of typical polymers that are used for coating of textile are conventionally PVC or polyurethane based. And so the idea to use PVB, that is also it's a transparent polymer for this type of application is really a challenge that for sure we are thinking to promote during Sunrise project execution. Another point is that we are thinking also to include different modification of the polymers formulation, including, for example, different type of inorganic or organic derivatives that could be mixed together with the polymer in a soluble form and can be applied directly on different textile substrates. So I have just reported here two common technologies like padding or roll-to-roll, just to say that the goal of the project is to use to work firstly on the development of a polymer in a solution way, but also including derivatives like powders or other type of inorganic or organic molecules or pigments, and to apply it directly on textile using conventional technology. So textile sector is searching innovative solution, but the idea is to apply this innovative option using conventional technologies that are available up to date on the market. So at the moment, we can say that there are really few case studies of application of PBB on textile structure. It means that more effort should be done on this specific field because probably at the moment the main interest is also to recycle the material for the same industrial application. But we are thinking that it could be really a good opportunity to perform an industrial test for application on different textile substrates. So there are some case studies mainly on application at yarn level, like for example on polyamide and polyester, that are sure are key materials for synthetic textiles. But sure, there are also other options like electrospan fibrous material that, for example, could be used also for application in insulation materials. For example, for coatings on insulation materials that are mainly based on non-wovens layer. Another interesting application that we pursue during the project execution is related to the substitution of PVB for application in carpet manufacturing. Also, this part is quite interesting because the main idea is to find different formulation, including recycled PVB to substitute lattice during the manufacturing of flooring material, mainly to substitute the back baking material lattice that is used in commercial application. So these are the two main target application that we are thinking to cover during the project itself. So these activities will be performed in combination between NTT and Radici Pietro, that is one of Italian company that is a leader on carpet manufacturing. And so we are thinking also to cooperate with them also to develop a different dispersion-based formulation, starting sure from the key parameters that at the moment are involved in the formulation of latex back coating for carpets. And for application of coatings on different textile substrate, we will involve a textile finishing line that sure is available at our site. So just to say that the final results that we are aiming to reach are quite ambitious, but also in line for the expectation also on the European textile strategy. So from our side, we will continue on this type of development and also try to find synergies with other industrial sector. That's all from my side.
Thanks, Daniele. I ask if someone has any question. Someone here in the room? Not at the moment. And I think also not from home at the moment, so you have time to think about it. And so now I ask to our other speaker, Alessandro Piovano. Hi, Alessandro.
Hi, nice to see you.
Nice to see you too, even if online. So in the meantime, you share your presentation. I just briefly introduce you. Alessandro is one of our partner. He took the PhD in Chemical and Material Sciences at the University of Torino, and is a researcher at the Politecnico di Torino since 2022, under the Professor Gerbaldi Claudio guidance. His research activities focused on the development of new materials for more performant and sustainable devices for energy storage, and their characterization through electrochemical and physiochemical methods. So Alessandro now is teaching also, not only at Politecnico di Torino, but also at the University of Montpellier. And as I said, is one of our partners, and is the, if I can say it, because before Angelica told about it, he's also the organizer of the webinar that we organize every 6 months and that are related to different topics in Sunrise project. So Alessandro, if you want to start with your presentation, you are welcome.
Thanks, and good afternoon to everybody. So I would like to start just briefly introducing our institution, that is the Polytechnic of Torino. That is one of the most important universities about architecture and engineering, and they strictly connected to the companies, and they promoted the development of several startups and spin-offs. In particular, our department is the Department of Applied Science and Technology. That is the second major department at the Polytechnic of Torino. It covers different scientific sectors, from the fundamental principles to their application at the lab scale, and in some cases also to pilot plants. The staff counts more than 150 professors and researchers, together with more than 200 postdocs and PhD students. In particular, our research group is the Group for Applied Materials and Electrochemistry, whose focus is the development of innovative, low-cost, and environmentally friendly materials for energy storage and conversion devices, such as lithium-ion batteries, in particular with focus to solid-state batteries, sodium-ion batteries, and also next-generation batteries that are based on different redox chemistry, such as the zinc-air batteries. The Game Lab is also part of an Italian consortium that is called GISEL, which groups together several Italian research centers and companies, and provide shared facilities and expertise. speaking about the alkali ion batteries, that they are the main technologies for electric vehicles and portable electronic devices. But despite their spread use, they still face many significant challenges related to the performances in order to improve the power that they are able to provide, the cost in order to use most cheaper and more abundant materials, the safety in order to avoid fire, explosion, leakages, and other hazards. And finally, the sustainability in order to reduce the use of critical raw materials and to increase the durability of the batteries. Just for a general introduction, batteries are commonly made by two electrodes, the anode and the cathode, an electrolyte and a separator. But if we wanted to see the materials inside the batteries, we have to take in mind that inside the electrodes, we have many materials, including the active materials, conductive carbons to provide the electric conduction, metal foils that are used as a current collector, and the binder. And with respect to all of these materials, the aim is always to try to break down the cost. Here you see two graphs in which you can see the composition of lithium-ion batteries and sodium-ion batteries with a different material and with the different cost of the materials. And in particular, the polymer material are present in the separator and in the binder that is present inside the electrodes. For what concern our role in Sunrise project, that is try to use the recycled PVB in batteries, we are exploring the possibility of using PVB as a binder that has a considerable impact on the cell performance because it provides the strength within the electrode substrate and provide a good contact between the electrode materials. In this case, according to our market research, our target cost is lower than $10 per kilo in order to be competitive with conventional binders such as the carboxymethyl cellulose and the polyvinylidene fluoride. We are also trying to use the recycled PVB as a separator that is placed between the anode and the cathode and prevent the electrical short circuits. In this case, the separator must be permeable for the liquid electrolyte. And in this case, the target cost is lower than $60 per kilogram with respect to the conventional separator that are based on polypropylene and polyethylene. And finally, the most ambitious and high risk and high gain, I would say, research is focused on the development of solid polymer electrolytes, so for all solid state batteries. In this case, the polymer membrane contains the electrolyte. In this way, there are low flammability, we can prevent leakages, and we can provide good thermal stability. But for achieving these very ambitious results, we have to chemically modify the polymer in order to enhance its mechanical and chemical properties and to provide sufficient compatibility with the movement of the ions inside. We have already done some preliminary attempts of preparing electrode with PVB as a binder. We started with pure commercial PVB for this preliminary test. For the preparation of the electrodes, first we have to prepare a slurry that contain a solvent and the solid content that is the material of the electrode. In particular, the solid content is composed by the active material that can vary depending on the anode or the cathode, the conductive carbon black, and the binder. Then the slurry is casted on a metal foil that is used as current collector. The dry laminate is then cut into discs and outgassed under vacuum at 100 degrees. And finally, the so prepared electrodes are tested within electrochemical cells. Our preliminary results of electrochemical test of these electrodes in galvanostatic cycling, both in lithium and sodium batteries. We used, in this case, as active material are the carbon, producing some anodes that are tested against lithium metal and sodium metal. And we compared these results with analog anodes with standard binders. As you can see from these graphs, the two electrodes are stable both in the lithium and in the sodium batteries, are stable towards many cycles, even at a very high current rate. But the performances are still a little bit lower with respect to standard binders. So some attempts to improve the performances are to add some oxalic acid in the slurry that polish the surface of the metal foil and increase the adhesion between the electrode and the current collector. To increase the amount of the binder in the slurry preparation, to test different solvents in order to modify and to properly tune the dispersion of the solid content and the viscosity of the slurry. And finally, to use to mix the PVB with other polymers, such as the polyvinyl pyrrolidone, as it is already reported in a few works in the literature. And then, of course, once we will have optimized the composition and the method for using a PVB as a binder, we will try to move from pure PVB to the recycled PVB. And we will evaluate the effect of plasticizers and of contaminations, as Angelica has already discussed in the previous talk. So I thank you all for the attention, and I would like just to recognize the work that is done by Dr. Amide Dairazzi and me, under the guidance of Professor Claudio Gerbaldi. And here are our contacts. So if you have any other curiosity or other suggestions, feel free also to contact us or ask now for the questions. Thank you very much.
Thanks, Alessandro. I ask if someone has any question. From a moment here. But I don't know, maybe you're so shy. No, don't be shy. You can ask questions. No, not yet. Okay, so we finished the presentation, so maybe we will be able to ask something. Okay. Perfect. Our next speakers is Matas Rudzikas, that is here with us. So I share your presentation, Matas, here on my computer.
Sorry. Okay. I leave you the floor. Stage is yours. Marcos is another of our partners. He's a researcher at the Modern E-Technologies and working in R&D activities, doing his PhD that is about advanced light filtering techniques to obtain efficient and color PV panels. And what is important for the growing building integrated photovoltaic market. So, Matas, the stage is yours.
Thank you. Good afternoon, everyone. I will talk a bit short technical matters, but we will also concentrate on a bit of our company and what we're doing and what we will do in this project as our main work package start only this year. The end of this year. There's a scheme of we are a group of companies. Like NET is a partner of the project in the lab, which is working on research and development of the products. And Net Solar is production of custom solar panels. And then we have also Net Energy is also research and development, but on the heat storage also. That is working on research with lower technological readiness level. The lab and Lediga is our spin-off. Very shortly about Net Solar, as possibly the company commercialize this product with PV. We are producing custom panels. Means you can see that, for example, many colors, different shapes, sizes, different materials, and also different applications like lighting in the streets to make it autonomous, tiles on the roof, and similar stuff. And also about modern technologies, which is the partner of the project working on the research and development. This is our activities. What we do is material synthesis, software methods, and energy efficient building solutions. As there's growing interest in building integrated photovoltaics, doing some research on tandem sources. What is the next step from our current market leader, Silicon, which is approaching saturation now. And if you want to improve efficiency, we need to go to the tandems. We are doing some simulations of solar cells, panels. Also, carbon footprint calculation is getting more and more important nowadays. Also, energy efficiency solutions for buildings and industrial processes. And some photos, we can turn we show some of our activities. Like here, we have a module system for data collection of power generation, and we are working on the artificial intelligence for fault detection in PV systems, meteorological station for collecting meteorological data. We're also doing some applications like this is a smart stand with some special mirror systems to generate more power. Doing some special panels like flexible, lightweight. Some special tests like hail tests to order to prepare the products which can withstand hail and some other mechanical damage. Also some, for example, seamless products, which can be like combined with some normal tiles on the roof. Also some research development of polar panels, which is one of my topic, but yet a bit needs more research to make it industrial. And in this project, we are using this recycled PVB. We will be using recycled PVB to make solar panels to test if it can be better than AVA, what is the other encapsulant, which is now normally usually used in the industry to laminate cells. So I think it's one of the most important things is to compare, and if you want to make it commercial, you want to make it somehow better in the final panel. So we will optimize the lamination process, then do some characterizations, and also do climatic tests to test if these panels can be reliable and withstand some like many years out in the field. So these climatic tests are like, for example, one of them is high temperature, high humidity, high and low temperature changing fastly. So they are testing some extreme conditions to see if materials can withstand it. And also, yeah, and we work like in a feedback way. We receive some sheets and we will try to make them, and we will get good results. We will try to improve it. Panels made with PVB should have better adhesion properties. What would actually result in a higher water lifetime? This is what we suppose. Also, because it's greener, it's a cheaper product, can be more competitive. The disadvantage of this material is that it has higher water penetration rate, what requires additional edge sealant into the panels not to allow water penetration. And also, lamination process can be more difficult because in some cases autoclave must be used. And yeah, also shown the comparison AVA with the PVB. So commercial AVA to use and PVB, commercial PVB, which we are now testing. So parameters are a bit similar, but not the same properties are shown. It's easy to compare. The comparison will be independent, and also a little bit results. In the middle, we see some glass piece, just laminated glass. Because in the first place, we don't need the solar cells. So lamination process was optimized to make it bubble-free. So first, we tried similar processes which we use for AVA. It doesn't work like this. So it needs a bit longer process, longer pressure. But however, after some thermocycling tests, we find out that a lot of bubbles here in laminating glass. So we will compete with this and do the backsheet. What is another, like in the industry, there are two main module types. One is glass. It's glass on both sides, and another is glass backsheet. And backsheet is some polymer, which allows it to make it a bit lighter, but a bit less resistant to some stuff. So in this case, we obtain the very low adhesion. We could tear it through the hand. So More tests will be needed. That's about it. And have any questions?
Okay. Any questions? Not? Questions from the audience and not here, but now you have to talk and asking questions because this second part of our event is organized as a roundtable. So the idea is asking you some questions and asking your feedbacks regarding the technology that Sunrise is developing. Angelica, do you want to?
Yes.
I give you the floor.
The questions and the audience has to answer, but okay.
If you want to stay here, I put you here the microphone.
Okay, so okay, the idea is to have your feedback. So I have think about some questions. Some of them are okay. We have here in the audience different perspectives. The ones from the recyclers, the ones from the manufacturers of glass, and the ones from the PV manufacturers. So some questions will be more focusing in some of these sectors, but of course everybody can provide their opinion. So first question probably is too broad the answer, but I would like also to ask, because we have been talking in Sunrise project about some challenges, the one from the glass contents, the one from the variability of types of PVB, from the aging, but at the end, the PVB is recycled in a minor quantity. So we have identified this challenge, but I would like to ask to the perspective to the recyclers if there are some another challenge that we are not addressing. It's like a very broad question, but there are some another challenge that could need to be addressed from your perspective. So I don't know. No. Okay. Okay, this is like the Santa's letter. You can wish you want.
I just don't understand one thing
Okay.
about this separation by categories of PVB previously.
Yeah.
This is why it's needed, and this will guarantee that you will be able to recycle all kind of categories of PVB for different streams later, or
Yeah.
or why?
We try to identify where we try to identify best. Okay, the criteria are composition and degradation. So, for example, in the case of composition, we try not to mix PVB with something that is not PVB. This is very clear, for example, or try to not mix mixtures of plasticizers with one plasticizer, because at the end, if we go to the application again of laminated glass, when we mix compositions, we could increase the haze. So all the categories could be recycled, but if we make in different batches, we will have a better quality category for one applications, potentially in laminated glass, and the others for other applications. So that's the reason.
Thank you.
I have one question here, I think, right?
My name is Ulrich. I'm the president of Verwehr, and we have seen a lot of information which is happening parallel to our business at the moment. My question is, how can we be of any help at the moment as recyclers? Of course, we recycle laminated glass, and we have a kind of PVB with impurities, or mainly it's glass dust. But what can we do today to support this project? We give a lot of data, of course, but how can we technically or however support it?
Okay, we have asked data, Badwin knows better, and also okay, we are not now going to go to the phase where we are going to have the sensor. So our idea will be to test this sensor with real waste. So your supply of waste is of interest, and also our idea could be also when we sort this waste in this sensor tool, one possibility could be we could treat in Lurederra with our pilot mechanical equipment, but it's not a realistic one. So we could make this per sorting in the project, and probably then we could give you the batches in order you could treat in your facilities batch by batch. We can visit also. Yes, and so technically, I think you could help. You are helping already, and you can still help technically making some tests with your equipment. So and all the ideas are welcome, and all the possibilities are welcome. Okay.
What is the size of glass or PVB you need to have to detect it with your sensor? Is a piece like this big enough, or because you are looking, as I understood it, from the whole glass, and there is of course many different sizes, and the glass is still on, and I see some, let's say, challenges in that.
Okay, so the prototype just now, what we do with our prototype, for example, we treat a lot of with windscreens, so we make in our facility some manual cutting, okay, in order to take a piece of 50 by 50 centimeters, okay. And this is the piece now in the prototype goes to the sensor, but we prepare the sample. Okay, we take the full windscreen and then prepare to take this piece in the prototype. In the future, the idea is to develop this system for of course, a limited size, okay, because we cannot take in consideration all the sizes, but the idea could be to have this sensor for with a bigger size, at least for the size of a full windscreen. Okay, but now for the prototype, we prepare the samples.
Are broken when it comes to recycling. Yeah.
That's a point. Also, Badwin mentioned before that, okay, the idea for this prototype should be that unless in the case of windscreens, we will have the full windscreen. So that's the issue of the aging outside or not, or trying to have more care with the waste. If finally this works, what we would like to have is as much best quality as better. So we should try to avoid this outside edging and broken aspects when do it specifically for the recycling. We know that in the case of the construction and demolition waste, it's impossible to have full because we will have a lot of broken pieces. This is a more challenging aspect, but in the case of the windscreen, the idea should have to have the full windscreen, even if it's broken with cracks, it's okay, but the full windscreen. Okay. So I have some another questions. So
Okay, yes,
okay, so
can proceed.
Okay, so one aspect we are going to start now in the project. Also, we have here Dean, Claudia from Dean in this aspect as support. We are going to try to make some standardization activities in the case of the PVB recycling. Okay, we are not talking about a European standard because it's not the frame time of the project. It's not what we can do it in this project, but there are some possibilities. Claudia explained us from DIN about some Sense and Elect Words of Agreement, which are some documents which can be the basis for a future standard. And which could describe technical specifications in the same way that, for example, there are technical specification for the characterization of PVC recyclates or quality requirements for application of some polymers in recyclates in products. So we would like to make something similar for PVB. This is something that needs a working group of 3 partners or less, if I'm not wrong, and it's open to other interested party. And I would like to know also your view from the recycling sector or from the manufacturer sectors, your view in the preparation of these technical specifications as a basis for a standard. If it could be useful, if you see useful this activity, if you would like to contribute in some way, or I don't know if somebody wants to add something of this. I don't know, if some manufacturer of PVB, for example.
Yeah, so.
Yeah, 1 minute.
So I'm in the company career field for the laminated glass. And one of the difficult point for our side to recycle PVB is that there's several different types of the PVB. Even it is like a similar film, but has a different characteristic and a different like a particle, like a material into the PVB. So even though it is like a clear that looks same, but it's actually different. And then using like a mixing the different type of the PVB makes more higher haze or like reduce some performance. So one of the things that kind of like interesting part is like I want to, if it is possible to increase some like a criteria to sorting more like a detail, then from the PVB supplier side, it's kind of interesting. We supply some of the material or like a characteristic, and then to support like a sorting of the PVB. That's yeah, I think from the PVB supplier side.
Perfect. Someone else that wants to give its contribution? Do you want? Sorry? Oh.
As glass recyclers, we are, let me call it, in the aftermarket. That means after the PVB has been produced. Is there anything, that's a question for you, that the producer of PVB is doing in future to make it easier for us?
You mean like
to change the PVB composition or whatever it is to make it easier to use it afterwards in the future? I know we have a lot of PVB already installed in windows, in cars and so on, but one day we will start with a new material. Are you changing something in your production for the future, for recycling, for sustainability?
I see. Not like close future, but at this moment we are, yeah. Yes, it's a difficult question. So at this moment, not clearly targeting to make it easy to recycle, but more focusing on like we can try to use like more like bio-based material to use for the PVB. That we are focusing on this moment, but not yet considering like how we can make it easy to recycle. That's still very early stage to research. To answer your question.
Oh yeah. I'm not happy with this answer. Because, for example, it could be interesting if you in your industry talk to each other. How can we reduce the variations of PVB? That we don't have, I don't know, 10 different PV types, just one in future.
I see. So I assume like each company have using a different like material, like for example like a plasticizer. So just out of idea is like using like a similar type of material among the industry could be the one of the solution to make it easy to like sorting or like make it easy to recycle. But it's kind of one of the challenging because using the different type of the material is a uniqueness for each company. So that's one of the challenging. But just out of idea that's one of the okay. Thank you.
Thank you.
So, this last question about making easier, there was a criteria that we are not considering, but in some occasions, different stakeholders have mentioned, which is try to avoid mixing acoustic from non-acoustic PVB, which probably, I don't know if in this project or in the future could be done, but which was not planned initially in the project. But the issue is again the same. If we mix both types, we increase the haze because different compositions and so on. But here, I don't know if for the PVB manufacturers, but for the glass manufacturers, it could be possible to label acoustic from non-acoustic, because I don't know. Is something okay? We are not going to label all the different types of PVB, but this is a category, acoustic PVB, that if you have a mark of acoustic PVB, it could be good to the end user to know that I am using a better laminated glass, but for the recyclers could be also better. So I don't know if somebody wants to answer. I come to you.
Yeah. So for my knowledge, like some glass manufacturer, like for some OEM glass has a mark of like acoustic. So some of the glass already have the mark, so easy to define it's acoustic. But depending on glass manufacturer and OEM, they don't disclose. So that's one of the challenging. But one of the idea is but that's why I agree with the idea, like requesting like a glass manufacturer, like OEM, to put some like a logo or like a simple mark to easy to identify the type of the PVBs.
Okay.
Yeah, maybe I'm gonna just to reply quickly as well on the flat glass manufacturing side. We might have big companies, but actually it accounts for peanuts compared to OEMs. So maybe this question needs to be addressed to OEMs, because they make the specifications and glass manufacturers just answer to those specifications.
So I don't okay, last questions. Not only because we have here this multi-sensor tool, we consider this multi-sensor tool as a new part in the mechanical laminated glass recyclers or glass recyclers. That could be a first step for this business. But I don't know if we think in another possibilities for, I don't know, for example, for glass manufacturers. I know that they have also a lot of waste from the industrial process because the effect of manufacturing. I don't know if in this case, this sensor could be of utility for something or not, because you already know the composition. So, but I don't know, to see if there could be some interest from that part also, or we put an additional sensor to detect something.
Answer. I'm afraid actually I cannot answer, but I can certainly relay the question to our members, but I don't have an answer for you today.
Sir, to this question? Online?
Yes, I can answer to the question. So I'm Perrine Label from AGC. So for me, there is an interest to have this type of tool, but it's not on the side of manufacturer. If we have some waste of post-industrial waste of laminated glass, it's more like after the laminated glass go to the recycler to recover the glass cullet, and so the tool will be helpful at the recycler partner, in fact, because we know that how who is what type of laminated glass we have, but one we deliver to the recycler, it's more complicated. So the tool will be helpful here at this place.
Okay, thanks. Many thanks for your contribution. Someone else online? No more questions from my side. I don't know if somebody wants to add something or to have some doubt about some part of the presentation.
Okay. So as Angelica told at the beginning of this event, we are going to organize other events. So for sure, in our next events, we will be more precise also on the results that the project will achieve and all the techniques that we are developing. So for sure, you are welcome to participate again here, but also at home. I stay here so they can see me. And if no one has any other question, I think that I just want to thank you very much for being with us today. We will send you a short questionnaire that I kindly ask you to answer. It will be very short, but it will be useful for us to understand better the challenges that we have to face during the project and your feedback. So many thanks for being here, and I hope to see you again in our next events. Goodbye.